What's up, my pre-calc people? I'm Michael Princhak. In this video, we're going to tackle the solutions to solving systems of equations in two variables. Now, you can access this free packet in the Ultimate Review packet. Use the link in the description below, and you can practice all these prerequisite skills on your own. And in this video, we're going to go over the answer keys to the solving systems of equations section of the packet. All right, let's dive into those solutions right now. When it comes to solving systems of equations in two variables, there's a couple different ways. My favorite is substitution because it usually works every time. You also have linear combinations, and you can also make a graph of each and find where they intersect. But in this particular problem, I want to show you how to use substitution method. So what you have to do is pick one of the two equations and solve for one of the variables. We usually choose the one equation where it's easier to solve for one variable, and that's going to be the second equation, 2x minus y equals 7. It's going to be pretty easy to solve for y without creating any fractions, which will make the work a little bit trickier. So we're going to subtract 2x from both sides and get negative y equals negative 2x plus 7. Divide everything by negative 1 and we get y equals 2x minus 7. Now the idea is we're going to take that value for y in terms of x and substitute it back into the other equation for y. So we get 3x minus 2, but instead of y, we're going to write 2x minus 7. Highly recommend using parentheses, especially when you have more than one term when you do substitution. Be very careful distributing that negative 2, so we get 3x minus 4x plus 14 equals 5. Combining like terms, 3x and negative 4x is negative 1x. Subtract 14 from both sides and we get negative 1x equals negative 9. Divide both sides by negative 1 and we get x equals 9. Now for the final step is taking that x and substituting it back over to here to solve for y. We know that y equals 2 times x, which we can replace with that 9, minus 7. 2 times 9 is 18. 18 minus 7 is, of course, 11. So our final answer for the two missing variables, x and y, is x equals 9 and y equals 11. Now, this problem we want to solve by using linear combinations. Now, to use linear combinations, what we want to do is we want to add the two equations together and get a variable to cancel. Now, if we add them right now, we're going to get 4x and 1y. So that could be a nice way that we could solve, but that's not going to get rid of the two variables. So what we want to do is we want to get them to match up. Like if we have a 3x here, we want this to be a negative 3x. That way when we add them, we get 0. Or if I had a negative 2y and this was a positive 2y, they could add up to get a 0. So we got a couple different options, but the easiest is going to be multiplying the bottom equation by negative 3. So the top equation is going to stay the same, 3x minus 2y equals 9. But when we multiply the bottom equation by negative 3, we get negative 3x minus 9y equals positive 24. Now when we add them, we're going to get those x's to cancel. We obviously have a couple different things we could do. We can multiply the bottom by positive 3 and the top by negative 1. That will turn the top into a negative 3x and the bottom to a positive 3x. We can also multiply the top by 3 and the bottom by 2 to get those to be negative and positive 6y's as well. A couple different options, all are going to get you the same final answers. But now when I add these together, I get 0x and I get negative 11y, and 9 and 24 is 33. Now, because there's no more x's, don't have to worry about them. Solve for y simply by dividing both sides by negative 11, and I get y equals negative 3. Now to solve for x, I'm going to take that y and I can plug it into either one of the original two equations for y and solve for x. So if I take the original equation, 3x minus 2, but instead of multiplying by y, I'm going to multiply by negative 3 equals 9. I get 3x plus 6 equals 9. Subtract 6 from both sides. 3x equals 3. Divide by 3 and x equals 1. That's how simple it is to use linear combinations. If it's simple to do, sometimes linear combinations can be a little bit tricky to do if it's not easy to get there to be one variable with positive and negative coefficient. But hey, this one worked out pretty nice, so hopefully that makes sense when it comes to solving linear equations.